Okay, we have this problem. Divide 2 by a complex number 3 plus I and express the result in the standard form of complex numbers, in a plus bi form. So this problem is essentially the same as rationalizing the denominator problem. So here is how we're going to solve this problem. We're going to multiply the numerator and the denominator by the same number. We're going to multiply top and bottom by the complex conjugate of the denominator. So 3 minus I over 3 minus I. And then we multiply numerators 2 times the whole thing, all of 3 minus I, over 3 plus I times 3 minus I. And this is, let's simplify the denominator first. Remember complex conjugate product theorem. When you multiply a complex number by its conjugate, their product is the real part 3 squared, which is 9, plus the imaginary part, the number, the coefficient of I squared. So in the numerator we still have 2 times 3 minus I. Now we have the denominator of 10. Then we can simplify this by canceling 2 out. Cancel 2 out, 5 is left in the denominator. So then this is 3 minus I over 5. Now we can separate the real part and the imaginary part of this complex number and write the answer as 3 over 5 minus 1 over 5 times I. Okay, I want to show you another example. So let's divide 2 plus 3i by 1 minus I. We apply the same idea and multiply both top and bottom by the complex conjugate of the denominator. So the complex conjugate of the denominator is 1 plus I. So multiply 1 plus I over 1 plus I. And we're going to compute the numerator and the denominator one at a time. So let's work out the numerator first. So the numerator is the product of 2 plus 3i and 1 plus I. So 2 plus 3i and 1 plus I, they consist of more than one term. So we're going to put them in parentheses. So parentheses 2 plus 3i times parentheses 1 plus I. Then we expand everything out. So 2 times 1 is 2. And 2 times I equals 2i. 3i times 1 is 3i. And then 3i times I is 3i squared. Now this I squared is again, negative 1. So the real part is 2 minus 3, which is negative 1. And the imaginary part is 2i plus 3i, which is 5i. So next we compute the denominator. So for the denominator, we're going to just apply the complex conjugate product theorem. So we have the real part 1. So we have 1 squared plus the imaginary part is, if you look at this negative I is equal to negative 1 times I. So negative 1 is the imaginary part. So take square of negative 1. And then that is 1 plus another 1, which is 2. So now this number is the numerator negative 1 plus 5i divided by the denominator 2. And if you separate the real and imaginary parts, that's negative 1 half plus 5 halves of I.